if we have 2 to the x equals 6 and we're trying to calculate log 2 of x and we're not using the base 2 because we don't have that in our calculator, well, from our activity the other day, you found if you wanted to solve for an exponent, you could take the log of both sides. So taking the log of both sides, wow, that was fancy. Taking the log of both sides would look like this. And doing that, one of the reasons we practiced our log laws and we expanded things or wrote things as a single log, here you could take that x and bring it out in front. That's one of your log laws. And then you get x log 2 equals log 6. At this point, if I wanted to get x by itself, I would need to divide both sides by log 2, and I get log 6 divided by log 2. So now going to our calculator, we've already got that log 2 of 6 was 2.58. Now for those of you that don't have that function, you can just go log of 6 divided by log of 2.
That's what our calculators do when we do a log 2 of 6, right?
They're figuring that out. So we get 2.584 that way. So off to the side here, I'm going to write that log 2 of 6 is equal to log 6 divided by log 2. Put that in a green box. Now I'm going to erase the work that we did and say I'm going to start again, but instead of taking the log of both sides, I'm going to take the natural log of both sides. So just like you can take the log of both sides, you could take the natural log of both sides. And the natural log is just a log with base e. So all of your log laws still stay the same. You can still say, oh, if I have an exponent inside the log, I can bring it out front and multiply. So that will be x natural log of 2 equals natural log of 6. And if I wanted to get x by itself, I divide both sides by the natural log of 2. Now if we go to our calculator, we have the natural log button right under the log button. So I'm going to check what happens if I do natural log of 6 divided by natural log of 2. So this too, if you didn't have the base of 2, if you didn't have the newest version of the calculator, you could type this in, and you get the same answer. So I'm going to put that in a purple box. Okay, we're going to do it one more time. On your calculator, the natural log button on your calculator is right below your log button. So when I hit this LN button, it gives me the same answer. Now we're going to do it one more time. Do you feel that there's like a number that's been unrepresented in math classes over your years? Well, so we're not going to use like just a regular whole number. No, it's 0 you use lots. 7, feeling like 7. So if I took log base 7 of both sides, would your log laws still be the same? Yes. So we can bring the x out in front just like we've done before. And then we could divide both sides by log base 7 of 2. Let's check if this is the same answer. Do you think it's going to be the same? Yes. Okay, let's see. Alpha window log base. So we got log base 7 of 6 divided by log base 7 of 2. Push enter, and sure enough, it also is the same. So I'm going to write that one off to the side as well. We have log base 2 of 6 is equal to log base 7 of 6 over log base 7 of 2. And I'll put that one in a red box. How many of these do you think we could find? Infinite. In fact, you could pick any number. Like here I chose 7. Here basically I'm choosing E. Here I'm choosing 10. But since your log laws stay the same for all of them, it's always going to be the same. And this is called the change of base theorem. There's a proof of it here on the next page, but what we're looking at is this at the bottom, the change of base theorem. On your formula sheet or up on the wall there, it's written this way. Log, I don't like, there we go. Log base A of m is equal to log B of m over log B of A. So some things to notice. I'm going to circle the A in purple. It's also here. I'm going to circle the M in red. It's also over here. But this B is only on the right-hand side of the formula, which means you can choose B to be anything you want. Just like we had here, right? First I chose it to be tens. And then I chose the natural log, which means it has a base of E. And then someone felt that 7 had been underrepresented in your math careers, so we chose 7. And it wouldn't matter whatever number you would like, you can choose. And that's the change of base theorem. So it's another law that you can use to manipulate or to simplify. Just like identities. So whenever you see, oh, I have a log divided by a log, then I can use the change of base theorem as long as my bases are the same. Then I can get rid of that and move it and change it to the left-hand side of this formula. And this is also very helpful for those of you that don't have the base on your calculator. Then you can figure out something like log 2 of 6 by making it log 6 divided by log 2. So let's look at example 1. It says approximate each of these values and write the related exponential expression. So if we let x equal log 5 of 50, first of all, if you were going to estimate x, would it be between 1 and 2, 2 and 3, 3 and 4, 4 and 5, 852 and 853? Between 2 and 3. How do you know that it's between 2 and 3? Well, 5 squared, if the exponent was 2, 5 squared would be 25. 5 cubed is 125. And if you think about the related exponential expression, which says the base is 5, my exponent is x, is equal to 50, then it would make sense that it's between 2 and 3. Now, if I'm going to figure that out, log 5 of 50, I go to my calculator, I can use the change of base theorem and say, well, that's the same as log 50 divided by log 5. And I get an answer between 2 and 3, so that appears to be correct. So you might even find, once you get good at this, it even feels quicker to use the change of base when typing in, rather than having to go through all of those second steps to find the different base. But if you wanted to find the different base, you could find it log 5 of 50. And notice we get the same answer. For the second one, log 8 of 6. So again, if we were thinking about this in exponential form, if we let x equal log 8 of 6, this is like saying 8 to what power is 6? And again, it's good to do some mental math and estimate. What is that going to be between?
0 and 1.
Between 0 and 1. Because 8 to the 0 is 1, 8 to the 1 is 8, So our answer should be between 0 and 1. And when going to our calculator to figure this out, again, you might use the change of base theorem and do log 6 divided by log 8. We get something between 0 and 1. Alternatively, you could type it in as log base 8 of 6, and notice we get the same answer. All right, so the questions for practice on this one are 3, 4, and 5.